students. Good evening. My name is Samuel Dominic Chukwuemeka, aka Sam Dom for Peace. In this video session, we shall discuss an application of piecewise function. Do you pay any bills? Power bill, water bill, cell phone bill? If you look at the receipt, of your power bill or water bill, you will see most likely that it is a piecewise function. And this is something you can give to your students. Usually, students in 8th grade and 9th grade, they do algebra 1, also pre-algebra. So, and one of the topics they learn is piecewise functions. And this is a topic you can give to them. You can also extend this learning. You can make it interdisciplinary by asking them to develop a calculator for it. For students that are learning programming languages, you can now ask them to develop calculator for it to extend the learning concept. So this topic is typically for our middle school students and high school students because some people do it in middle school, some do it in high school. And also, it is also good for students that are taking technology as electives or taking some other computer science class. So please, the easiest way to get to the website is from my website. You can click on any of these websites, samuelchukwuemeka.com or chukwuemekasamuel.com, and you can click on the link or the secured link, whichever one. Okay, I'm just going to click on this one, Control plus click. And then when you get on my website, you click on mathematics, you click on algebra, and under the notes section, you click piecewise defined functions. I would want to start with a story. The story is good, and also it exposes the students to have an idea of what they are learning and why they are learning it, as well as it is also a little bit funny. So, but because of I have to do this video in 30 minutes. I have a 30-minute window limit. I have a 30-minute limit to do the video. So I'm going to skip the story. However, it is good that if you're using this as the lesson, it is good to begin with the story so the students will understand what they're about to learn. So under applications, I have this. For this video, we shall do Georgia Power. Yeah, but I mentioned about power bill and water bill. The income taxes is also piecewise function as well. Of course, in America, it is required that you pay tax. So the state tax and income taxes are also good applications of piecewise functions. So you just click on Georgia Power, and we're just going to go to the actual information, which is on this website here, Georgia Public Service Commission. But this is the information here. As you can see from this information, the basic service is $10. So if you live in the state of Georgia and you're using the services of Georgia Power, even if you don't consume any kilowatt hour of electricity, electricity is measured in kilowatt hour. Power, or electricity is measured in kilowatt hour. So even if you don't consume any power, let me just call it power, or you can call it electricity, you must pay $10, even if you don't consume any power at all. This basic service, the monthly basic service is $10. And then you have 3 tiers. And this is for the summer rate. This is for the summer residential service rate for the summer. The summer period is from June to September. So, because we also have for winter rates. So you have 3 tiers. The first tier is up to 650 kilowatt hour. This means kilowatt hour. It is the unit of power for the United States. Up to 650 kilowatt hour is 0.056582 dollars per kilowatt hour. That is the first tier. The second tier, they said the next 350 kilowatt hour, and that goes for 0.093983 per kilowatt hour. Then any power consumption over 1,000 kilowatt hour falls in the third tier, and that is 0.097273 dollars per kilowatt hour. So it is important that you do not round these numbers, okay? We are going to use them as is. You only round in the final answer, only. So we are going to start with a manual method or arithmetic method. I call it manual method or arithmetic method to calculate the costs for consuming this amount of power. So we are going to do it by manual method or arithmetic method. Then we now go to the main thing we want to learn, piecewise function. And this is important so that students will appreciate the learning of algebra. Yeah, because when they do this manual method and then they now do the piecewise function, and they now see, oh, with piecewise function, I don't need to go through a lot of steps to get the answer. Once I just get the function, I just substitute the value in the function that falls within that domain, and I get my answer. So it is important to start with manual arithmetic method for students to appreciate algebra, especially to appreciate why they are learning piecewise functions. So we're going to find the cost for a resident that consumes this amount of power in a month. We are going to first solve it by a manual method or arithmetic method. Then we now solve it algebraically by piecewise function method. So the first thing is to describe your variables. Let P be the power in kilowatt hour, and let R be the cost in dollars per kilowatt hour. So the first one, 0 kilowatt hour, of course, is the basic service, $10. Okay. 300 kilowatt hour, as you can see here, this has 3 pieces. It has 3 pieces. Okay. When you have 300 kilowatt hour, it falls in this first tier, because this first tier is up to 650 kilowatt hour. Yeah. The basic service is basic, no matter what. Okay, this is basic. Then you have these three tiers, these three pieces. Yeah. So for a resident that consumes 300 kilowatt hour is in the first tier. Okay, I'll call it the first tier right now, but because we are doing piecewise functions, you will see that it falls in the first piece. Yeah, in their website, they called it first tier. However, because you're now teaching the topic piecewise, which means several pieces, you can use first piece. Okay, so this is 0.056582 per kilowatt hour. So you just multiply it by 300. Okay, when you multiply it by 300, it gives you 16.9746. Please do not round. Do not round intermediate calculations. Please do not. So once you do that, you must add the basic fee. The basic fee is required whether there is any power consumption or not. So the basic fee applies to all three tiers. So you now add it to that and it gives you 26.9746. The next one is 700 kilowatt hour. This falls in the second piece. So before we find the cost for 700 kilowatt hour, because 700 kilowatt hour is more than 650. Okay, from 0 kilowatt hour to 650 kilowatt hour is the first piece, first tier. But once it is more than 650, it falls in the second tier. So the next 350 is more than 650 to 1,000 kilowatt hour. Okay, that is the second tier. So 700 kilowatt hour falls in the second piece. And before you solve it, you have to pass through the first piece first. So we say, okay, for the first piece, the maximum is 650. Right? For the first piece, the maximum is 650 kilowatt hour. So multiply it by that cost for the first piece, and you get a 36.7783. What is remaining? 700 minus 650, which is 50. So you now find the cost for the remaining 50. That remaining 50 will be evaluated at this rate. Okay, the 50 that is remaining will now be evaluated at this rate. So you now multiply 50 by 0.093983. Okay, when you do that, you have 4.69915. So you add the basic fee, which is the $10, plus the cost for the first piece, the whole thing you can get in the first piece, plus the cost for the second piece, the remaining cost for the second piece, and you get this. Okay, you only round at the final answer, dollars and cents. So you round to 2 decimal places. The same technique is what we use for 1,000 kilowatt hour, the same technique, okay, because it falls in the second piece as well. If we do the 1,200 kilowatt hour, this falls in the third piece. So for 1,200 kilowatt hour, we first of all have to get 650 out of it, multiply by this rate. Then we get 350 out of it, multiply by this rate, and then the remaining will be 200. Okay, because 1,200 minus 1,000 is 200. The 200 will now be multiplied at this rate. And we add the basic fee. Okay, so that is what we did here. And when you do that, the basic fee plus the maximum cost for the first piece, maximum cost for the second piece, and the remaining cost for the third piece. And you have this. Okay? You have that. $99.13. All right. The main work. So students shouldn't have a problem doing this manual method. I would encourage you to first of all ask them to solve it themselves before doing it for them. Let them just solve it, and they shouldn't have a problem doing it arithmetically. But the thing now comes to piecewise, and you can ask them this: okay, what if we have so many bills to calculate? I mean, the state of Georgia, you can imagine the population is in millions. And then if you have to calculate the power consumption for so many customers, you cannot just keep doing it manually or by arithmetic. You cannot. So you have to design a computer program. You have to give this to a programmer. And for the programmer to develop the computer program for it, the programmer would not develop it just by looking at it like this. No. And that is why piecewise function is needed. The programmer would develop it when it has been done as a piecewise function. Then it's easy for a computer programmer to develop the program. So the first thing we have to do here is we define our variables as well. We can say let P be the power consumed and let C be the cost per kilowatt hour. You can use R, it doesn't matter. Just use any variables that make sense, okay? So this means that C is a function of P. C is the dependent variable, the cost, and the P is the independent variable, the power consumed. So the cost depends on the power. And this is what your students already know in algebra. So we now say, okay, cost for P kilowatt hour. Now, the basic fee is still $10, but cost for P kilowatt hour, because now we are using variables, okay? So we now say for the first piece, cost for P kilowatt hour at this rate, at the rate for the first piece. So this is P times 0.056582. And that gives us 0.056582p. Then you have to add the 10, because the $10, like I said, is the basic fee for all the pieces. For the second piece, you have to finish with the first piece. So the first piece, the maximum is 650. So you still have to finish with the 650, okay, multiply it by that rate for the second piece, add it to the 10, it gives you this. Then the remaining P, okay, because for you to do the second piece, you must finish the first piece. And that first piece, you have to get the maximum the maximum amount you can pay for the first piece. Any amount over that will be charged at the rate of the second piece. So remember, we did 700 in the arithmetic method. So rather than saying 700, we now say P. Okay, and this is where this gets a little bit confusing, that you have to explain to the student. You can ask the student, okay, remember how we did the arithmetic method for 700? We did 700 minus 650, and it gave us 50. And we multiply that 50 with the rate for the second piece. So instead of saying 700, we now say P. Okay, we now say P. That's the thing, that's the only difference here. Okay, rather than doing 700, we now say P. And of course, you distribute when you distribute, you simplify. You make sure you simplify. And this is what we get for the second piece. For the third piece, we have the basic service. Then we have the maximum amount that we can spend for the first piece. Then we also have to do maximum amount we can spend for the second piece. Of course, the next 350 times that amount, the rate for the second piece. Then the remaining, we call it P, okay, minus 1,000, because that will be charged at the third piece. The third piece. Okay, so we have the basic fee, we have the maximum amount that can be paid for the first piece, we do the maximum amount that can be paid for the second piece, and then the remaining, which is now anything over 1,000, okay, falls in the third piece. So anything over 1,000, which is now P minus 1,000, just like we did 1,200. In the arithmetic method, we did 1,200 minus 1,000. So you have to multiply that with the rate for the third piece. You distribute and you simplify. So you now have your piecewise function here. Okay, these are the pieces here. This is the domain. This is the function for the first piece. This is the domain for the first piece, which means this means that any power consumed that includes 0 and 650, okay, between 0 and 650, the both endpoints are inclusive. Here is between 650 and 1,000. This one, the 650 is not included, okay? So if you were representing it in interval notation, you ask your student, okay, are you going to use the parenthesis or a bracket to represent this in interval notation? You can connect with that prior knowledge, okay? And this one is over 1,000. Now, some people might write this, they might represent this with a infinity, but you want them to write it like this, okay? Over 1,000, anything over 1,000. And also ask them, why shouldn't the domains overlap? That's a good question to ask the students. Why didn't I put less than or equal to in this second piece, for the lower bound? For the lower bound, why did I not put less than or equal to? Okay, and for this third piece, why did I not put greater than or equal to? So why the domains did not overlap? You can ask them that question. All right, the nice thing about piecewise function is I just know, okay, I want to calculate 0, what piece falls in the first piece? I just do this times 0 plus 10, that's it. 300 falls in the first piece, so I use this function, 0.056582 times 300 plus 10. That's it. 700, I know it falls in the second piece, so I use this function right away. 0.093983 times 700 minus 14.31065. So you see, I just do it like 2 steps. I substitute and I solve, rather than going through several steps like I did in the arithmetic method. So that is, and when you read the story here, you will really understand, that's why the story here really gives that explanation why piecewise functions are great. Okay, let's get back to this here. So this is the piecewise function, so it makes it so easy. You know where it falls. 1,200 falls in the third piece. You just substitute it and calculate it. Further, if you have students that are taking technology or programming courses, and if you're teaching them programming, they can develop a calculator for this. They can develop a calculator for this, and they can test it. If you test this works, okay? And if you want to use this as a project, because I use this as a project for my students, You can, under this project here, you can look at what I require for my students, and you can look at them and see if it's, if it's something that you can use for your students. So, but I know my students are learning from it. They have to do both they have to do the arithmetic method first, then they do the piecewise function, then they develop calculator for it. That is for the computer science students. And for the mathematics students, they just have to do the arithmetic method and the algebraic method. But not only that, not only mathematical skills, this project tests for several skills. Okay, research. They have to find any application that uses piecewise function that I have not done. There are so many applications, there are so many cities and counties in the United States that use piecewise functions. So they need to, go and do some research. Then they write it out. They also cite their sources using APA, MLA, or Chicago Manual of Style. So this is a project that there are so many things you can test for your students, and they will really learn something from it. Okay. If you have any questions, feel free to contact me through my website. You can contact me through my website, or you can contact me in the session from the in the summit, the Wonder Workshop International STEAM Summit. Okay, we are all in this together for our students, and we want them to succeed. We want them to learn, and we want them to apply what they learned. So this is one of the applications you can use with them to apply what they learned. Okay. Thank you so much for listening. I wish you all the best, and you have a great year.